Hello everyone. So today we are going to solve some Leetcode hard level problems for kth smallest element which we have learned in the previous video. So if you have not watched out that video first, I would strongly suggest you to go and watch out that video first on kth smallest element. What is that topic? How do the questions come and all those kind of queries if you have on kth smallest element. You just go and watch out that video. Today we'll be going to solve two lead code hard questions related to this topic. So the first question says that nearly everyone has used the multiplication table. The multiplication table of size m cross n is an integer matrix where matrix of ij is equal to I into j, one indexed, if we considered one indexed. Given three integers m, n, and k, we have to return the kth smallest element in the m cross n multiplication table. Okay, let me draw and made you explain only. So you are given 3 cross 3 multiplication table. So this is your 3 cross 3 might be a multiplication table. So this will be first row, first column. As they have said, consider one index, then only the formula will be I into j. Second row, second column, third row, third column. Now 1, 2, 3, 2, 4, 6, 3, 6, 9. This will be your multiplication table of size m cross n, which is 3 cross 3 here. And you have to return the fifth smallest element. Now to make you clear, this your m and n could be until 1e4. So 10 raised to 4. It could be until 10 raised to 4. So for sure, you cannot make the multiplication table. You cannot make the matrix or the multiplication table. Okay, why? 10 raised to 4 cross 10 raised to 4. This will be the size of it, which is 10 raised to 8. This we cannot make. Maximum we can make is of 1000, 10 raised to 3 and 10 raised to 3, which will be 10 raised to 6. Until that point is still okay. We cannot make the table of size 10 cross 4, 10 raised to 4 cross 10 raised to 4. 10 raised to 8 space will not be able to get an integer. So what is the other solution now? You know, for every row the fixed number of digits, because this will remain fixed. You know the formula. Okay, what you have to do, you have to count the number of elements. What we will do first, the step will be count number of elements less than n, less than mid. Okay, we'll consider one mid. We'll count number of elements less than mid, and that count should be greater than or equal to n. Sure, because what we want is nth smallest element or kth smallest element. Sorry, what is given? Kth smallest element. Then this should be greater than or equal to k. This is your kth smallest element. Now the question lies here. The binary search part, you know what you have to do. Okay. If you found this condition true, then r is equal to mid. You will check from L to mid. Otherwise, you will do L as mid plus 1. So you will check from mid plus 1 to r. You know this condition now. So the question arises is to find the number of elements, count the number of elements less than mid. How we will do that? How we will do that? Okay, let me draw this again over here for 3 cross 3. 1, 2, 3, 2, 4, 6, 3, 6, and 9. And your, let's say, consider, okay, for sure, your L will be what? 1, and your R will be I into J, or sorry, M into N maximum. So here 3 cross 3, 9. So your answer could be in between 1 and 9 only. Okay. Let's say your mid is 5. Okay. Your mid is 5. Now you have to find the number of elements less than 5 in this first row. So you are going for the first row. So your all answer, if you have at max columns, you didn't know how many number of columns you have. Okay. You could have so many columns. Then how many maximum integers? How many maximum integers could be less than mid? Mid divided by row, which is 5 divided by 1, which is 5. So for row 1, it could go until 1, 2, 3, 4, 5. We didn't know how many columns are there. But we have only 3 columns. So we'll take the minimum of this 5 and 3, which is 3. Now you are in the second row. Okay, for second row, this will be 5 divided by 2, which is what? 2. So it is saying only two numbers can be less than 5, 2 and 4. From third number, it will be greater than 5 only. And that is seen to be true also in this example. So 2 or 3, minimum of 2 or 3, which is 2. So the formula sets is minimum of mid divided by I, where I is what? Row starting from 1 to m, and n. N will be what? Total number of columns. Hope you have got why minimum of mid by I and n. Mid by I because if we consider that we have maximum number of columns, okay, we didn't know how many, but let's say consider we have infinite number of columns. But still for infinite number of columns also, let's say for third row, how many numbers can be less than 5? 5 divided by 3. Only one number can be less than 5, which is 3. From the another number, it will be of course greater than 5. Okay, so this could be 1. But what total number of columns I have? Okay, as we have seen in the first example, there could be 5 divided by 1. 5 numbers less than or equal to 5. That is true. But columns only we have 3 only. So if 3 columns are there, then of course 3 will be counted in the first row. So it could be minimum of mid by I and n, total number of columns. So now you know how to solve this, and you have that template also. Let's quickly solve the question itself. Okay, let's solve this. So now no need of making this multiplication table, as we cannot make it because we are given the range of 10 raised to 4. Okay, fine. We have L as 1, R is m cross n, while R minus L greater than 1. Mid will be R L plus R minus L by 2. If is possible for mid, m, n and k, m is the rows and n is the columns. Okay, if is possible, then R will be mid because we have to find the smallest, else L will be mid plus 1. For smallest, we'll check first for the R. So if is possible for L, we'll first check for L, M, N and K. Will return L, otherwise we'll return R. Now this is your main function. Bull is possible. This will be mid, M, N and K. What we will do, we have to count the number of elements less than or equal to mid. That should be greater than or equal to K. We'll go to each row. So for int I is equal to 1 till I less than or equal to m. What I will count? Minimum of this mid divided by I or n, total number of columns. And this count should be greater than or equal to k. You can see this is actually Leetcode hard, but as we know the topic, as we know how to do it, this formula, count number of elements less than equal to mid, that should be greater than equal to k. It has become actually very easy now. All this type of questions comes under Leetcode hard level, but as we know the template, as we know how to solve it, this has become easy. Let's quickly see another question. So we have another question. Let me paste it over here. Okay, so the question says that a positive integer is magical if it is divisible by either a or b. Positive integer is said to be magical if it is divisible by either a or b. And for all this, okay, one thing I wanted to remember, for all this type of problems, the time complexity will be n log n. I've mentioned it very earlier when we do binary search and answer. Most probably it will be n log n. But it again depends on the question. How is your is possible function? Okay, how is your is possible function? It depends on that. Given three integers n, a and b, we have to return nth magical number. Again, nth magical number or kth smallest or nth magical. Here it couldn't be smallest because that couldn't be repetitive. The same way upper, if they have called you kth number, then also it's okay, but they have mentioned kth smallest element. its kth element also, because it, no, this could repeat. Okay, 6 and 6 two times it repeats. So when it repeats, it's smallest. When there are no chances of repetition, then it's okay. So now we have to find, for example, let's say you will be given n as 4, a as 2, and b as 3. If the, since the answer may be large, we have to return it modulo 10 raised to 9 plus 7. Okay, n is 4, a is 2, and b is 3. Starting from the first, starting from 1, starting from 1, we need to find all those numbers which are divisible by either a or b, and from that too we have to find the fourth number, fourth magical number. Okay, so 1, is 1 divisible by a, or is 1 divisible by 2 or 3? No. Is 2 divisible by 2 or 3? Yes. Is 3? Yes. 4? Yes. 5? No. 6? Yes. 7? No. 8? Yes. So you will see all unique numbers will only come. Okay. All unique numbers will only come. That's why it's return nth magical number. But whatever pattern we have learned, kth smallest, same only. If it is not unique, then they say kth smallest or nth smallest. So the fourth magical number is 6. So we have to return 6 for this scenario. So now what we will do? Again, the same logic, the same everything. What we will do? We'll go for mid. We'll go for mid. We will find number of elements. Sorry, 1 minute. Okay. We'll find number of elements less than or equal to mid. And that count should be greater than or equal to n. This is fixed. But now again, the question arises where? In is possible function. That is greedy approach. That is brute force. That is logical type of functions which you have to make. So the question arises, how we will count the number of elements which are divisible by a or b, either a or b. So if mid is the number, okay, if mid is the number, what we need to find? Mid is which number? We need to find the number. We have to find the counts which are less than equal to mid, but is still divisible by either a or b. Okay, just a simple question. If your n, if your number, not this n related to, let's say your some number, random number is 15 and your a is 2, how will you determine how many numbers from 1 to 15 is divisible by 2? 15 divided by 2 karke. 15 divided by 2 is what? 7. So there are 7 numbers from 1 to 15 which is divisible by 2. How we will know? 2, 4, 6, 8, 10, 12, 14. There are total 7 numbers. Let's say if my a is 3, how will I know how many numbers are divisible by 3 from 1 to 15? Of course, 15 divided by 3, which is 5. There are total 5 numbers from 1 to 15 which is divisible by 3. 3 is, there are total, which is divisible by 3. So 3, 6, 9, 12, and 15 from 1 to 15. Correct? Now, if there is a as 2, b as 3, so there are total 7 numbers from this, 5 numbers from this. Now I have to subtract those numbers. So from 2 it will be 2, 4, 6, 8, 10, 12, and 14. So there are this number 6 and this number 12. These are the two common numbers in both of them. So I need to remove those common numbers. How will I remove? I need to find the LCM of 2 and 3. LCM of 2 and 3 is what? 6. So the numbers which are divisible by 6, that I need to remove because that has came twice. So 15 divided by 6 is what? 2. Which two numbers are divisible by 6 from 1 to 15? 6 and 12. So those are the only two numbers, 6 and 12, which has came twice. So I'll remove once. So I'll do 7 plus 5 minus 6. So now you got the logic of how to find the number of elements. Count number of elements less than equal to mid, which is divisible by either A or B. They have said either A or B, not both. If both, then simply LCM for sure. So it should be number divided by A plus number divided by B minus number divided by LCM of A and B. Now, let me just clarify you. If you want to find the GCD of two numbers, there is an STL library called dash dash GCD of A comma B. This is the way to find the GCD, direct STL library. So LCM is what? LCM of any number is what? A into B divided by its GCD. That's where we get LCM. And now I hope you are clear with this so we can solve the question. So let's just quickly solve this question. But everything should have to be in the long long and your final answer should have to be modulo M. Okay? It should have been modulo M. So your numbers are given until 1 10 raised to 9. So you will be given n, nth number should be 10 raised to 9. So on the better side, we will take the integer range in this. Okay, L is 0 and R is 10 raised to 18 or long long range, maximum long long range. This we will take as our boundary because we are not sure which number could it be. It could be any number. That's why we will take this. Okay, but every time we'll find the solution, we will do it modulo 10 raised to 9 plus 7. I hope you got my point. And we will take everything as the long long. Okay. Yes. So let's just quickly solve this. Okay. First, let's make this bull is possible. We will be given int mid, no, not int. It will be long long. Long long mid and then int a, int b and int n because this three will be integers as given. We will have count. Count is the number of elements less than equal to mid which is divisible by either a or b. So first we'll need to find the GCD. So GCD will be what? Underscore underscore GCD of a comma b. Okay, but as both a and b are integers, you will get the GCD also in the integer format. But now when you are counting it, first we will do mid divided by a. So mid into 1 ll divided by a into 1 ll. So we are making this both a long long. Mid is anyways long long, but a is not. So we are making a and mid both as of now long long. Now we have to do mid into 1 ll divided by b into 1 ll. Now, of course, we need to find the LCM also. Okay, so LCM we will find a long long. That will be what? A into B divided by GCD of AB. So GCD we have already found. Okay, so we have to count, subtract this mid numbers divided by LCM. Those both are anyways long long. So if we want to do this 1 ll, then also it's okay, but it's fine. And we will return this count should be greater than or equal to n. Okay. Now here we have L as 0, R is 118 for the maximum range, while R minus L greater than 1. Mid will be L plus R minus L divided by 2. If is possible for mid A, B and N, we will do R as mid, else L as mid plus 1. Okay. After coming out, if it is possible for L, A, B and N, we will return L modulo M, else we will return R mod else we will return R modulo M. And M you have to define always on the top. So wherever this modulo given, okay, we'll define it as constant modulo M 1e9 plus 7 on the top. This is the best way to write. Okay, let's just run and see whether it's correct or not. Cool. This is also a lead code hard level question. So now you know it. Okay, here the function is also very easy, is possible. If you know a little bit of maths, you will know how to find from 1 to n. So these are easy level questions now after knowing this logic of K's smallest element. So in the next video, I'll be covering more such type of questions. Stay tuned, stay safe until that. Do like, share, and subscribe if you have learned a lot out of this. Bye bye.